So we're here at the British Computer Society's office with Alan O'Donoghue, who was principal teacher at Our Lady's Catholic High School up in Preston, one of the early generation of CAS master teachers, the founder of the Raspberry Jam movement, and now is a specialist leader in education for EXA Networks. Alan is very much one of the Python gurus amongst the CAS community, so we thought we'd take this opportunity to ask him a few questions about Python. Let's start then with one of the basics. What is Python?
So Python is a text-based programming language that works on pretty much any computing platform like Windows, Mac, Linux, and some other variations on those as well.
And what makes Python such a good first choice for a text-based programming language?
Well, a lot of people don't actually know that Python was actually designed specifically to make it suitable for learning. It wasn't designed as a programming language to do X or Y. It was meant to be something that people could pick up more easily than other programming languages. So that makes it an ideal first text-based programming language for many people, including myself. The other notable feature about Python is its structure. When you write it is all based on spacing. So some programming languages, other ones like JavaScript, Java, they're based on the blocks within the coding are based on brackets and braces. So it makes, because Python's based on spacing, it makes it more kind of human and more sort of readable. One of the other things about Python that a lot of people don't realise in a school context is it's actually a real programming language. It's not, while it was designed so people could learn how to use it, it's not just meant for education. So lots of large organisations like Google and YouTube already use it. And in fact, the company I work for, EXA, they're an internet service provider, and many of the protocols that they rely on for the internet to work, things like protocols and their proxies, they've all been implemented in Python. And because they can be shared online through things like GitHub, and people can then go in and contribute to the development of those if they want. So it's all about open and sharing.
So how would you go about introducing Python to a new Year 7 class?
That's a really interesting question, because I'd actually say, why would you want to start with a Year 7 class? I have myself, I've taught it to many Year 7 classes, but then I suppose one of the things I think about if I was to do that with a Year 7 class is Scratch, which is another favourite tool of mine, has got so many opportunities within for fun and engaging learning experiences. Why should we let primary schools have the monopoly on teaching with Scratch? However, if we decided, no, we absolutely must teach this to a Year 7 class, there's a variety of approaches you can go for. So you might go for one of the approaches that maybe when you were taught at school, like the teacher stands at the front of the class and says, here's Python, here's how you do that. So you've got the kind of university lecture approach. You might provide children with worksheets or some kind of online learning environment, say go work through all of those. But I feel that both those approaches lose and miss out lots of unique learning opportunities. Really, in my experience, I found the best times have been when you show children the power of it, something small to begin with, and then you ask them to make predictions about what might happen next, and then probably interrogate them a little bit about why would you say that would happen, and what if we did this, and well, that's an interesting idea, and not to confirm whether they're right or wrong, but just to explore it, and then we see whether their prediction was correct, and then we explore the conclusions. And then other things you might then do is you might then explore, in the first instance, things like basic input and output, mathematical operators, so like adding things together, bits of data. You then start to go into things like, data can be stored in different ways, so there's things like strings and integers and that sort of thing. And then where it becomes quite powerful is the children then might write something that will take some data from the user, so it'll take an input. Then it does something algorithmically with that, it could be a little bit of magic, tell me a number and I'll take that number and I'll add something to it. Okay, that doesn't sound that exciting, but it can be, there is potential to do that. And then it presents the original thing back to the user in a way where the user kind of goes whoa. So I've done this with teachers, for example. So most people start teaching at the age of about 23 or 24. So I could ask you little bits of information, and then you can go back to people and say, this is the year you started teaching. People go, oh my goodness, how did it work that out? But it's just based on some simple little rules and things. So then you're showing children some small little tools and functions within Python, and then you're asking them to creatively apply that to a given scenario or situation, and that's where the real learning and magic really takes place.
What challenges might a pupil encounter then as they move from the block-based language of Scratch to the text-based language of Python?
I'd say without a doubt syntax is the biggest challenge that you're going to face. It's not your enemy as a teacher, it's just something that you have to wrestle with. So while Scratch is all very lovely, it's based on blocks, graphical blocks, and the blocks, if you've looked at Scratch, you'll see that they're almost like jigsaw pieces. So certain blocks fit together in certain ways, and you try and join those two blocks together, and they just won't. Python doesn't have that within it. It does kind of, it's implicit within it, but you don't see the fact that it is. So just like, we're conversing in the English language, and the English language has rules and conventions about how to use it, like sentences with capital S and full stops. Well, the very same is true of Python. It also has rules and conventions that you must or are expected to follow. So when you are teaching a text-based programming language in the first place, if you decide you're going to do that, well, you can model things in Scratch and they work pretty much, but then when you go to build them in something like Python, you can actually build the real thing that will work in the real world, but then you've got those kind of challenges, which is like if you've got the syntax wrong, you get unexpected results or that sort of thing.
So what debugging strategies would help, and how would you go about teaching them?
So this is important because we can split that question into two parts, because there's sort of what debugging strategies do you use, and then there's the ones that you teach. So if we're talking about pedagogy, again you've got a variety of choices you might go for. So you could be super helpful. What's the matter? Your code's not working. Oh, tappity tappity tap, and I fixed it for you. But then the child or the learner is sat there thinking, what did he do? I don't understand. And what you're really doing it by being wonderful and fixing the children's solutions for them, it's actually going to lead to you being totally exhausted and exasperated. And also, you're teaching the children bad habits, which is high dependency upon you as a teacher. You're going to get to the staff from a break time or lunch, you're going to be absolutely exhausted, like, I don't know what's going on with that class, they're learning nothing. But actually, they are learning something, they're learning dependency on you. So I would really say rule that approach out altogether. The other one you can then is the flip side, is you can be totally unhelpful. Child puts their hand up. Miss, sir, my code's not working. You can go and say, oh yeah, why have you put your hand up to tell me? And the child's like, because I want you to fix it. My job's not to fix the code for you. I'll tell you what you do, fix it, and then when you fixed it, then put your hand up and we'll come over and we'll high-five each other or whatever. And then the children are going to go, what, you're supposed to teach us and I'm not learning anything? And then the children become sort of they don't enjoy the subject as much. Then there's another one, so you'll have heard some variation on this, the 3 before me approach, where people say use your brain, look in a book, ask your buddy before you then ask the teacher. So that's an approach that some schools
or
use.
Indeed Google the error list.
Well, yes. Stack Overflow, it comes in really handy for that sort of thing. Now, early on, so I didn't have a computer science background before like 4 or 5 years ago. And this was causing me quite a lot of angst and anxiety in my class. Like, children feel like they're not learning anything, they were hitting these barriers all the time, they were seeing all these red error messages. And then one day I hit upon this idea I call sabotage, where the children might start with something that you previously have prepared, like that you've tested, it works perfectly, or it might be something that they've already created themselves. And then what they do is they keep then a second version. And in collaboration with a partner, they then deliberately hide in certain errors within the code. Now, you might set up, like you might say, well, we're going to allow, you can change the case of things, you can have punctuation in, and then somebody says, oh, can we delete? Well, no. So you can sort of set up some boundaries and guidelines to begin with.
Do you focus on syntax errors there?
Well,
or do you introduce logical errors?
Well, that's the nice thing about this. There's a complete flexibility. At this approach that I've just been talking about, at this stage, I'm just talking about syntax errors, because I feel syntax errors are the most common thing and they're the hardest thing to understand in the first place. And then I think following on from that, then we can look at semantic or logical errors where you don't get what you want, but it appears to run and execute. So the thing about sabotage is you have the two partners, they work together, they've collaborated and like, yeah, we're really going to catch some people out with this. And then one of the partners goes to another pair while another partner comes. And then you have this sort of mentoring, coaching. It's like, well, come on, see if you can find the errors. Oh, you're doing pretty good at this, yeah? Okay, I'll give you a clue. Look at line 3. So what they're then doing is they're then helping each other. But the real beauty of sabotage comes later on. I don't mean later in that lesson. I mean lessons later when the hand goes up. Miss, sir, my code's not working. And you say, oh, I wonder has somebody sabotaged it. And that word sabotage is almost like a trigger where they think, oh, because of course when you're teaching and using sabotage, you would talk about, well, what are the kind of things we should be checking for? Like, what constitutes a syntax error? Would it be spacing? And you shared an example recently on Twitter where it was almost like somebody created this like diagnostic diagram. They were shared it through some kind of open resource. That'd be quite a good thing to share as well, but something like that.
I wonder about pupils who've got special educational needs or disabilities or for whom English is an additional language. Is the additional cognitive load of programming in Python or any other text-based language make things particularly challenging for them? What particular strategies could help there?
The strange thing that I found is that some children totally, they have, it's hard to use words to describe it, but completely confound your expectations. So I've taught children with special education needs. I've had like a class that there was 5 children in it in year 9, and these were the children who had really struggled to get their level 5 in maths and English. And there were 2 of them in that class, and they were working on things as complex and as demanding as things in my top sets that I was teaching. But then there was other children, and they found it more of a significant challenge than anything else. And they were saying things like, "Oh, sir, please, can we just go back to like making websites and creating games from scratch?" And there was one girl called Lauren, and she was one of the more challenged children in the class. And she'd done this thing where she'd taken a game and she'd added her own little expressions within it. And the others were saying in the class, "How did you figure out how to do this?" She was like, And I've actually, this is a remarkable thing I've noticed as well. I found some children that I've taught, after we've done things like sabotage, they're actually learning strategies that they can apply to other aspects of their learning. And
it's
I think
building a resilience.
That's right, exactly.
There, isn't it?
And I found that some of these children, where it is a small group that I'm talking about, they actually really respond to that rigidity, that the syntax or the programming language, because they like things to be exactly predictable.
So Alan, do you think that there will be some children who just never get this? Is it going to be too difficult for some pupils in a class?
This kind of goes down to the nature-nurture thing, which is, I don't think it's beyond everybody. I think everybody can understand a little bit of it. But there are influences, things like how motivated the child is, how new it is, whether the challenge is, they see it as being too steep, or whether they see it just slightly above or below what they can do already. So
and
I think it's
key
a very
factors like whether it's being explained well and whether the young
yes,
person is
exactly.
working hard at this
and,
is going to matter.
And why do we need to do this? I'm not going to be a software developer. Why should I have to learn how to program? And that's quite hard.
Do you have a counter to that argument? I don't want to be a software engineer when I grow up. Why should I learn to program in Python?
Well, I'd turn this around and I'd say, well, surely this is the same question as, why do we need to study RE? I don't want to be a priest. Why do we need to study maths? It's like we're doing Pythagoras. I'm never going to use that. So it is the same thing. I like to believe that when we're teaching this, we're not just teaching the children how to program or computing. We're actually developing the whole child. And through the problem-solving aspects that Python allows you, it's a tool that you can use to solve problems. It's helping you with your developing yourself as an individual and how you deal with challenges, full stop.
Can you give me some examples then of things which would really motivate pupils to learn Python? I'm thinking perhaps of things which you can do in Python that you couldn't do in Scratch.
So yes, I mean, we can look at Python in isolation its own and say, well, what can you actually do with it? And this is a question that teachers often ask me. Oh, okay, well, I've seen this and I've seen Hello World, but what actually use does it? And you say, well, you know when you use this thing called Google and you search for something, there's actually an algorithm in there which is built in Python. Oh, so it's like a real language. Well, yes, this is and it's like the first time you mention it's a real language, that's just sort of gone in one ear and out the other. I mentioned before, the company I work for, the internet service provider, so part of their duty is to make sure that when children are surfing online in an educational environment, there's certain websites and things they can't get onto. But rather than just blocking them, they've developed a proxy that uses Python, and it has to be robust because there's like legal requirements there in terms of duty of care. But I don't think kids are going to find that really exciting, really, to say what proxy.
Might be an ambitious programming project for yourself.
Absolutely. But if you really want to fire children's imagination, now at the moment Minecraft is still a bit of a hot topic,
yes.
And I've seen children at some of the Raspberry Jams I've been to build things like, for example, within Minecraft. So if you use Minecraft on the Raspberry Pi, it has a tool that's called an API. Well, that's actually Python as a tool, which means Python can then send things to Minecraft. So your inputs and your outputs, rather than just happen in the text, things happen in the Minecraft world. So one of the Raspberry Jam events I was at, we had a drone in the room, and the drone was flying around, and people were trying to figure out how is this drone being controlled, and it was being controlled by a user moving around in Minecraft, and people were like, whoa, this is so cool. Like as you move forward in Minecraft, the drone moved forward. Okay, that's a Raspberry Pi, but then you realise one of the limits for somebody was like, well, let's see how high we can fly in the Minecraft world, except we were in a building and the drone hit the ceiling and then crashed down. And and there was another example where a child had created a script that would build a space shuttle. But not only build the space shuttle, but then it used another API within Twitter. So when you said space shuttle launch with the correct hashtag, you could actually see the shuttle fly in the Minecraft world, and that could be controlled by anybody. I don't know if you've seen, I've got a Dalek that I got from a charity shop. I've put a Raspberry Pi inside that. I've put that down on the floor in my kitchen, and people anywhere on Twitter can tweet certain things, and it will interact with my Dalek, all using Python. But then you kind of have to say, well, but today we're going to learn how to get it to say hello. So that's sort of be like, but when do we get to do these kind of things? So one of the nice ways to demonstrate that is to show children some games that already exist. So they're not having to type in 150, 200 lines, but then ask them to try and modify the game, change the game. Sometimes they do it so they get an advantage over their opponents, but they hide what they've done. So it's like, here, Miles, try the game. Oh, come on, Miles, you're not very good. Look, I'm amazing at this game. And because what they've done is they've put in some little hidden bits of script that make the game behave in a different way. So the first thing I'm going to do is I'm going to open a piece of software on my computer. Now, people call this piece of software Python, but it's not. It's called IDLE. It's an integrated development environment, which is called IDLE, named after Eric Idle, like Monty Python, and that sort of thing. And often when it opens at first, people are a little bit confused, like it looks like Notepad. It's a text editor, and I could type something in now, like I could type in gibberish and press enter, and it just comes back and it says it doesn't understand what this gibberish is. Now, what I've got is, I opened up earlier, I've got a script here called Guess, and it's from Al Sweigert's Guess the Number game. And there are, how many? If we go to the very bottom, there's 34 lines. And now I want to execute that script. And what it now does is it now swaps over to what's called the interactive shell, and it says, what's your name? So I'm going to type my name in as Alan. And it says, well, Alan, I'm thinking of a number between 1 and 20, take a guess. Now, there's a thing we talk about called wolf fencing, where you try and figure out, so I could say 10 or 11, that would be a good guess. I'm going to go for 11. My guess is too low, so I need to go higher again. So it's not going to be 11, it could be 20, somewhere between 11 and 20, let me try 16. Oh! wow! It says, "Good job, Alan. You guessed my number in 2 guesses." That's probably that's a good record to me. And we've caught it on film as well. So there's a really, really interesting little process going on here in the background, which is, if you can look at the code that I've got at the top, it says import random, which is a module that allows you to choose the computer to pick a random number, asks what your name is. But it's this here. There's a loop that runs through it, and it's quite significant because it's saying, while the number of guesses taken is less than 6, take a guess. And then it adds 1 to your guesses taken. So if you've had 2 guesses, it adds 1 on. And then it does this. It has this sort of conditional element where it says, if the guess that you gave is lower than the actual number, your guess is too low. If it's bigger than the number, your guess is too high. But of course, it could be equal to the number. It might not meet either of those 2 conditions, and in which case it breaks out of that loop that it's iterating through. So we can start to do an experiment with a few things like, what happens, you were talking about semantic or logical errors before, what happens if we change those operators so they're actually the other way around? So Miles, can you pretend you're a year 11, so Miles, can you predict what's going to happen if we swap the operators the other way around?
The questions are going to be the wrong way around, aren't they?
Well, now you can't see this code I've got on my screen at the moment. So you said 11, and I'm going to say to you, oh, your guess is too low. So if I've actually swapped the operators the other way around,
that actually means it's too high.
The hints.
Yes.
So the computer's lying to us.
Yes.
Yeah. So it says it's too high. So we go, oh, well, I'll go for 5, and it's still too high. And then before time, you realise you've had 6 guesses, and you've probably got down to 2 was the number you thought it could be, and actually it comes out the number is 18. And you think, it lied to me. So you can build in all these kind of interesting little things.
Because this is getting the player to implement binary search.
Exactly. Yes. So it's putting all the emphasis on the player to solve the problem, and then the other things. What if we gave the player 1 guess, or what if we didn't give him a guess, or what if it wasn't a random number? What if it was always the same fixed number? And you've played this game 10 times. It's always the number 16. Oh, this time I'll guess the number 16. But then you could build something in and say, oh, if they actually think it's 16. Choose another number, so you can build in all kind of all kind of mischievous behaviour within this, and I think that's where the children have the fun, and and then some of them said, does it have to say, hello, what is your name? Like, what if it was Elvis or Justin Bieber or Kylie? How would it speak differently? And would it say, like, your guess is too low, or would it say, well, hey there, sugar, try go for a higher guess, that sort of thing. And you can just have all sorts of fun and change it. It could insult people. Oh, you imbecile! You've guessed way too high,
And this experience of tinkering with somebody else's code seems to be a very good way into
and then
writing your own.
The bit where you make some kind of fatal amendment or modification doesn't work anymore. Oh, I guess we're just going to go back to the original and start all over again. So I think from my experience, I've found that a really engaging exercise. And one measure of that is when the children start saying, how could I make it do this? And I go, I could show you, but it might be better for you to work it out yourself, because again, some people talk about you create this pit for the learners. If the pit is so deep that they feel they're never going to get out of it, oh, that's too hard, we're never going to be able to do that. But if it's just the right level of challenge, you go, would it be something to do with this? And they go, and then they feel the ownership, they feel like they actually had the solution themselves. Like, we didn't need that teacher, he did a lot of rubbish anyway.
Are there limitations to Python? Is there going to come a point where a young person feels that they need to move on to perhaps a more sophisticated language? Are there things that you wouldn't use Python for?
There's 2 aspects to that question. So when you say to move on, I hope what you don't mean is they're like, well, we taught them Python last week. We taught them Scratch last week. This week we're teaching them Python. What should we teach next week? Because we're not actually teaching the programming language. We're teaching children how to solve problems.
Yes.
And the tools that we're using are computer hardware and software.
And the concepts of computer science through the medium of particular languages.
So if you said...
Are there concepts that we can't get to through Python?
Well, there's some where Python may not be the most appropriate tool. Like, for example, if it's just understanding about how sequencing works, the fact that, you know, one action, another, you might not necessarily use Python to teach something like that. You might use something like a bbot or a logo, and Python does have lots of things like logo modules within it. Where if you said, oh, I've got this idea, I want to build this interactive web page where it does this and it tells, well, you probably wouldn't use Python. There is a framework within Python you could use, but you might think, well, a nice little bit of JavaScript, I can find something online, I can just plug that into a bit of HTML. And so certainly developing web applications, Python might not be top of your list. If you want to make a game that's going to be released on the Xbox, that's some high powerful 3D interactive game, again, Python's probably not going to be fast enough because of it's a high level language, which you'd probably want something a bit more powerful and faster, like based on C, something like, which is a much more low level language. So, but in terms of learning, in terms of all of the requirements, say for GCSE computing or GCSE computer science, Python is one really, really good solution. Some schools are using Small Basic, JavaScript, Java, and you might choose one of them instead. I just happen to...
Other languages.
Yeah, that's right. Yeah. I feel like when I was looking back in 2011, when I was looking for the best programming language that I could use to teach, I felt like I went around the Monopoly board a few times and passed Python, and then when I got to there I didn't need to carry on looking anymore.
So the step up from blocks to text is obviously a challenge for some students. I suspect it also is for teachers, though. What about for the teacher who's never programmed in Python before, who's been told that that's the language they're going to be using in Key Stage 3? What would you recommend for them? How should they go about learning this language?
So, you might not agree with me, but I think it's worth saying that if you're just learning how to use Python now for the first time, or how to teach text-based programming with Python, you're actually in a much better situation than some people were 3 or 4 years ago, because there's an abundance of resources at the moment, and in a way it's almost embarrassing how many. It's like you go to the supermarket and you're starving, it's like, oh, there's all these wonderful things to eat. So there are some of the kind of traditional things out there, like books and websites, and there's loads. One of the nice things about Python got going for it is there are so many free books, because there aren't all these licensing issues that you can download. And some people may choose to download one of these free books and work their way through some of the exercises, adapt them to fit themselves.
And are there particular books you'd recommend? Do you mind naming names? No,
would
you rather not say?
No, I will say one, but I also feel a little bit like the doctor saying, Miles, take this medicine because this works for all my patients. Okay. Because I think you kind of have to find a book that works for you.
Fair point.
For me, I made great friends with an author called Al Swigert, who I think lives in California, but he's written a series of books, and if you can remember, inventwithpython.com, there's about 5 books on there. You can download them for free, you can print them out, you can even print out chapters of the book and then loan them or hire them to your pupils for £1. When they finish with it, they bring it back, they get their £1 back, or they swap for another one. There's also, you can put them on your VLE, your learning platform. There's lots of different ways. But some people have tried books and books don't work, because book is like you follow a sequence. There's no iteration, or there's no conditionals built into the book. So the other thing is, there are lots of online things as well that have a little bit more interaction, and people will talk about things like Khan Academy and Code Academy. And again, for some people and in some contexts and scenarios, that's a useful thing, as long as you don't think, oh, I can just sit my children in front of Code Academy and they're going to learn all that they need to do. I think it's a useful thing to help them practice. But I would say fundamentally the best advice I can give to a teacher who's decided now, well, I feel I need to know a lot more about Python, is to try and meet somebody face to face. And your Computing at School Regional Centre will be able to go a long way towards helping you with that. So for example, they'll be coordinating hub meetings in your area. They'll already know who are the master teachers in the area that you can speak to, and some of them, like myself, are offering training events that you can go to, and some of them are free, some of them are very small charge. But the real difference is, once you're sat down with somebody and you're not feeling like this pressure that the bell going to ring, and you can sit next to somebody and actually, but how would you go about this, and how you'll just really, really feel that that investment will pay off much better in the future. And that's one of the big things that really helped me.
Alan, this has been so interesting. Thank you ever so much
Thank
for your
you.
time. Is there anything else you'd like to add?
I'm super excited that, you know, I think in 2011, when I had this idea in my head, right, I'm going to start teaching computing in my school, and I asked some people who were software developers that were new friends that I just met, I said, so, and one or two of them are like, well, you need to get yourself one of these nice, and I said, well, how much is, well, £1,000, £1,500, and I thought, I need to be able to use something that in my classroom is more affordable. And we were also using some of these expensive software development suites, software suites in school by the big proprietary companies, and children were wanting to download and use it at home, and the license were like £500. So when this little device here came out, I was like, wow, this is going to be fantastic.
That would be a Raspberry Pi.
It's the Raspberry Pi.
Yes.
And for around the price of £20. So you don't actually need one of these. One of these does the job just as well. And then there was one that came out that was free with a magazine, or that you can buy for £4, and you think, wow, that's all I need in order to be able to do that. And now we're just at the point where lots of children all over the country are going to receive one of these in their hands, the BBC Microbit, and there's actually a Python integrated development environment called MicroPython that is now available for the Microbit. That's easy to remember, isn't it? More easy to remember than it is to say MicroPython or the Microbit.
Yes. Excellent. Thank you very much.
Thank you.
Thank you.